Worksheet 13C, strain transformation and generalized Hooke's law. A 60-degree strain process is used to measure the strains on a structure made of 2014 T6 aluminum. Determine the principal stresses and the maximum in-plane shear stress. At this point, they give us epsilon A, 1000 micro inch over inch, epsilon B, negative 1500 micro inch over inch, and epsilon C, 2000 micro inch over inch. So basically, this problem combine problem worksheet 13a and 13b. So first, we need to use the three equation. Epsilon A is equal to epsilon x cosine square theta A plus epsilon y sine square theta A plus gamma xy cosine theta A sine theta A, etc. That from lesson from worksheet 13a, so that you will determine the 2D state of strain block for this point. And just remind you, A go to x-axis, so theta A in this case equal to 0, theta B 60, negative 60 degree, etc. So that the process will be the same, and then we move on to the process we did in worksheet 13b. So combine A and B, we can see. So with that, I don't go into write out all of that equation again, and just get to the solution and explain the solution to you here. So let's go to the solution. And with that, as you can see, for aluminum, we this problem doesn't give us the Young modulus, Poisson ratio, and the modulus of rigidity, but you can go to the appendix B for the aluminum 2014 T6. You can be able to find out the modulus of elasticity and modulus of rigidity and the Poisson ratio from the reference data card that you have. Then from that reference, we'll be able to get E equal to 10.9 10 power 6 psi new. You can apply the equation E over 2g minus 1, that if less than 2, you can have 0.4, and then G from the appendix B, you can get that 3.9 10 power 6 psi. So that is the material. So in the real life, no one give you all. You need to get the appropriate preferences to get the correct material properties, physical properties, geometrical properties, etc. So as I mentioned earlier, we can go ahead to use three equations from the rod set, strain rod set in there. And you see that in here, the first angle for A, theta A is 0, theta B at its clockwise rotation, so from X, so it's negative, and then theta C, another 60 degrees, so it's negative 120 degrees. So keep that in mind, clockwise rotation negative, counterclockwise positive for this. And with that equation, we can have simplified, and so that process similar to 13a, what I'm talking right now, 13a. So you have three equations, three unknowns. You can find out epsilon x 1000 micro, epsilon y 0. Oh, good news. Simplify our calculation later on. Gamma xy is 4041 micro radians. Radians. And from that, we can stay up strain. So here, epsilon x, as you can see, 1000 micro, and gamma xy is 4041 micro, and it's positive. That's why it go up to the positive x-axis in the positive x-plane, as you can see here. Epsilon y equals 0, so nothing in there. And that finished worksheet 13a there, right? But now 13c combines 13a and 13b. Now move on to the next. You need to draw the Morse circle for strain to find out epsilon y, epsilon 1, epsilon 2, and gamma max. Exactly the same. So you need to find out the epsilon average and gamma max over 2. So we can draw the Mohr circle. Draw the Mohr circle. And for Mohr circle, from the Mohr, we can be able to find out the epsilon 1 equal to epsilon average 500 plus gamma max over 2, 2081. You get 2581. And then epsilon 2, you get 500 epsilon average minus the radius, which is gamma max over 2, 2081. You get negative 1581 micro. So epsilon 1. Gamma max over 2 equal to the radius 2081. And then go back to the positive x plane and y plane as you recall. So for this case, the state of strain, and you can see epsilon x positive, gamma xy. If you use equation in this case, it's positive because they go to the positive y-axis. But for the Mohr circle, the gamma xy in the positive x plane, which is the vertical plane on the right, rotate counterclockwise. It will be negative. That's why your x, positive x plane, the vertical plane, located below here to 1000 and negative 21, which is the gamma over 2, gamma xy over 2. And the opposite, it will be the positive y plane, 0. And as you can see, exactly on the vertical axis gamma over 2 and plus 21, which is gamma over xy over 2 on the positive y plane. And of course that we can find out theta p1, theta p2 with your protractor. I just keep it in here. Use your protractor. We can measure it about that. So we can be able to find out which plane from the positive x-axis principal plane, theta p1 equal to 76. So you have theta p1 divided by 2, 38 degrees. And from everything is from the positive x plane. So as you can see in this, it will be counterclockwise. Similarly, theta x 7 degrees clockwise, because that 2 theta x is 14 degrees. So theta x clockwise, as you can see here. And then you can also determine the other angles from the positive x-axis. For example, we can determine the angle for theta p2 by measure this angle. This is 2 theta p2, and at theta p1 you can see it 83 degrees, and theta p1 plus theta p2 have to be 90 degrees. So you also have theta p2 equal to 90 degrees minus 38, or you can measure the angle directly. It will be 52 degrees. And you need to show what is the direction. In this case, clockwise. And you can see that clockwise. That's one. And 2 theta x, actually that is 2 theta x 1, as you can see here. You can be able to find out 2 theta x2 from the positive x-axis. Positive x-axis to gamma max up here, and that is 2 theta x2. And that one, as you can see, the plus theta s1, theta s2 and s1 have to be 90 degrees. So you also have be able to find out theta s2 equal to 83 degrees. And in this case, as you can see, that is counterclockwise. So that you can have on the answer. So that I just expanded. The question may not ask us to find that down, but I just expanded there for you to have it here. And then from the epsilon 1, epsilon 2, you can use the generalized Hooke law, which is the second video in worksheet 13b. Similar to that, we have sigma 1 and then sigma 2, sigma 1 25.3 ksi, sigma 2, the second principal stresses, negative 7.12 ksi. So the negative stand for the in that direction, the axis 2, the normal stress in this case create a compression for the block. And tau max, it can be applied either sigma 1 minus sigma 2 over 2 based on this equation, or if you go back to the worksheet 13b, you can also say, or tau max, it can be determined by chi times gamma max. And the gamma max, we find out from the Mohr circle gamma max over 2 equal to 2081. So you can find that out and should get a similar answer with the chi for the aluminum, which is 3.9 10 power 6 psi. So with that, we done for this problem, and you can see that is a combination of worksheet 13a and 13b. So it will be a long process.